This is Chapter 3, Section 1, titled What is a Function? A function is when one value depends on another. For example, when the fact that temperature depends on the date, that means that temperature is a function of the date. Another example, the area of a circle depends on the radius, so we would say that the area of a circle is a function of its radius. When you see the following notation here, this is saying f of x is equal to 2x squared plus 5. The f with the parentheses x is pronounced f of x. And when you see f of x equals 2x squared plus 5, this means that our function, or that we have a function involving x, and that function is 2x squared plus 5. If we have f of x equals 2x squared plus 5, and we want to find f of 3, this means we are saying that f of 3 is equal to 2 times 3 squared plus 5. We are evaluating the function or the equation at x equals 3. It's kind of like saying, given the equation y equals 2x squared plus 5, sorry, let's try spelling this correctly. Evaluate this equation at x equals 3. These two things right here are telling you to do the same thing. We have always solved equations by plugging in numbers for x. This is just written in function notation telling you to do the same thing. So f of 3 tells you to plug in x equal to 3. So you plug in the 3 and you get 3 squared is 9, and 2 times 9 is 18, and 18 plus 5 is 23. So the function evaluated at 3 is equal to 23. If you are setting up a table, f of x is the same thing as y. So if you're setting up a table of values and you need to plug in values for x, we would put 3 and our f of x, or our y value, would be 23. And knowing that, this would give us an ordered pair that is a solution to the function. Okay? So let's look at the definition of a function. A function is a rule that assigns exactly one element, f of x, to each element of x. So that means no matter what function of, no matter what value of x I plug in, I will only get one value as an answer. Okay, no matter what x goes in to the function, there is only one answer, which is the value of y. We could also look at this and understand functions by looking at this function machine. Here we have a function machine, okay, looking like this candy wrapper thing here, and f representing the function. So if we say that this function machine right now is working on the function x minus 3, if I put in x, my output is f of x. So the fact that I am putting in x right here, putting in x, my output is x minus 3. So looking at these examples here, if I plug in x and subtract 3 from x, I would end up with x minus 3. If I plug in 5 and I subtract 3 from 5, my answer is 2. If I plug in 9 and subtract 3, my answer is 6. And if I plug in 4 and I subtract 3, my answer is negative 7. So I'm just simply plugging in numbers in for x in my answer, which is y, or now we can know it as f of x. So think about that like when you're plugging in and making a table of values and you're plugging in all your values of x, then you plug in, get your answer, and those values are your y values, now known as f of x, the function evaluated at the value of x that we plug in. Okay? All right, so let's go on and look at some examples here. Here we have an example where we have f of x is equal to x squared plus 2x. We need to evaluate this in 5 different or 6 different values. Oops, I forgot f of a. Okay, so that's why I was thinking 5, but there's 6. So we want to evaluate the function at these 6 values: 0, 3, negative 3, a, negative x, and x plus 1. So all we do is plug in our values in place of x and get an answer. So for 0, we're going to have f of 0 is equal to 0 squared plus 2 times 0. Well, 0 squared plus 2 times 0 is 0 plus 0, which is equal to 0. So the function evaluated at 0 is equal to 0. For f of 3, we take f of 3 and we take 3 and plug it in for x. So we get 3 squared plus 2 times 3, which is 9 plus 6, which is equal to 15. So the function evaluated at 3 is equal to 15. Same thing here with f of negative 3. If we plug in negative 3, we will get negative 3, obviously in parentheses, squared, plus 2 times negative 3. That gives us 9 plus a negative 6 or minus 6, which gives us 3. So the function evaluated at negative 3 is equal to 3. When I plug in a, that just simply means that I'm replacing x with a. So remember our function was f of x equals x squared plus 2x. So in place of x, I am just replacing x with a. So I get a squared plus 2a. There's nothing more that I can do, so that is our answer. With negative x, I plug in the negative x squared plus 2 times negative x. And all I can do here is just simplify and understand that negative x squared is the same thing as positive x squared. And 2 times negative x would be negative 2x. So this would just be minus 2x. So the function evaluated at negative x is x squared minus 2x. And for f of x plus 1, this gives us the x plus 1 squared. Now let me write that better. Plus 1 squared plus 2 times the x plus 1. And now we have to simplify this. And when we square x plus 1 squared means we are taking x plus 1 times x plus 1, and we're going to FOIL or box method, whichever method you choose. And we get x times x, which is x squared, x times 1, which is x, 1 times x, which is another x, and 1 times 1, which is 1. So we end up with x squared plus 2x plus 1. And that is just my x plus 1 squared. So I get x squared plus 2x plus 1. Now with the 2 times x plus 1, I have to distribute the 2 and then continue writing it down here, and I get plus 2x plus 2. Now I'm going to combine like terms. I've got 2x plus 2x, which is 4x, so I get x squared plus 4x, and I have positive 1 and positive 2. Add those together, 4 plus 3. So the function evaluated at x plus 1 is equal to x squared plus 4x plus 3. And as an ordered pair, that would be, let me go through all of these as ordered pairs. So here, our ordered pair, we plugged in 0 for x, and our outcome was 0. So our ordered pair is 0, 0. For f of 3, we plugged in 3 for x, and our answer was 15. So the ordered pair is 315. F of negative 3, we plugged in negative 3 for x, and our answer was 3 for the y. So we end up with negative 3, positive 3. For a, we plugged in a, and our answer was a squared plus 2a. So our ordered pair is just two variable expressions. Same thing with negative x. We plugged in negative x. Our answer was x squared minus 2x. And for x plus 1, we put in x plus 1, and our answer was x squared plus 4x plus 3. And that is our ordered pair for that one. All right. So it's just evaluating the equation. You're plugging in values for x, and you're getting an answer. And instead of saying y equals, we're saying the function evaluated at whatever number or value you plug in is equal to whatever our answer is. Okay. Now looking at piecewise functions. Piecewise functions is when you have a combination of two or more functions, and the function to use to evaluate a given value will be determined by an inequality. So let's look at the example right here. If I have f of x and I'm given two options, I have x, f of x equals x if my values of x are going to be less than or equal to 0. So I kind of have f of x equals x when x is less than or equal to 0. And then my other option of f of x is x minus 3. And that is when my values of x are greater than 0. So I have f of x equals x minus 3 when x is greater than 0. So we need to pay attention to the inequality so that we know exactly which equation we are supposed to use and why. Okay? So if I have to evaluate f of negative 3, you have to ask yourself, is negative 3 less than or equal to 0 or greater than 0? Well, negative 3 is less than or equal to 0, and when x is less than or equal to 0, we are supposed to use f of x equals x. So I'm going to have f of negative 3 equals negative 3. So we're using f of x equals x. And so therefore, our answer is negative 3. When we are talking about f of 2, again, ask yourself, is 2 less than or equal to 0 or greater than 0? Well, 2 is greater than 0, which means we are going to take f of x is equal to x minus 3, because that is the equation or the function that we are supposed to use when x is greater than 0. So we're going to use the function f of x equals x minus 3. And so f of 2 is just simply doing 2 minus 3, which is equal to negative 1. So f of 2 equals negative 1. So these are our answers from evaluating f of negative 3 and f of 2. That's what we are doing with piecewise functions for now, is understanding how to use the equations when we are given specific values. And quite honestly, I forgot to put an equal sign here. This should say f of x equals, and then this bracket, so that you understand that it's f of x equals x if your x values are less than or equal to 0, or f of x is equal to x minus 3 if the values of x are greater than 0. All right, one last thing. We've actually talked about domain before, so hopefully this is a bit, good review. Domain is your values of x for a function, and the domain is the domain of the function. We need to find out what values can actually be evaluated. All right, the domain of a function starts out with the assumption that we use all real numbers. Okay, that's when we have no restrictions. The domain of a function starts out with the assumption that all real numbers are available. We need to determine if there is a reason that they will not work. The following examples here are going to be examples where we are restricted with our use of all real numbers. So our restrictions are, our restrictions here are 1 over some kind of expression, and that expression cannot equal 0. And what we need to do is we need to set the expression from the denominator, the expression that's in the denominator. We're going to set that equal to 0 and solve that to find out what numbers are restricted. Other than that, all other real numbers are available. So if we have 1 over x plus 2, we would take x plus 2, and we have to say, okay, x plus 2 cannot equal 0. So we're going to subtract 2, and we get x cannot equal negative 2. So that means every real number is available to use for this equation or function except for negative 2. So we would say our domain is x such that x cannot equal negative 2. And that is the understanding that all real numbers except negative 2. As interval notation, we would write negative infinity to negative 2, parenthesis, union, parenthesis, negative 2 to positive infinity. This is saying go from negative infinity all the way to negative 2, but jump over and skip over the negative 2 and then continue on to positive infinity. All right? It doesn't matter if there is even a variable in the numerator. If we have even x plus 5 in the numerator, that does not affect anything about this. So I could have written x plus 5 up here, and I would do the same thing here to understand my domain. Okay, all we are focused on is the denominator because that is where the restriction is. Looking at the second restriction, it's when we have the square root of some kind of expression. And what we need to do is set that expression to be greater than or equal to 0, because we cannot have a negative number underneath the radical. So therefore, we set the expression to be greater than or equal to 0. So if I have an example of the square root of x plus 5, that means I know that whatever is underneath the radical, which is x plus 5 right now, that has to be greater than or equal to 0. And then I solve and I would subtract 5, and I would understand and know that x has to be greater than or equal to negative 5. And so my domain would be x such that x is greater than or equal to negative 5. And all the real numbers greater than or equal to negative 5 are available to plug in for a, or x plus 5. As interval notation, I would have a bracket with negative 5 going on to positive infinity with a parenthesis. All right, so the reason to understand domain is so that we aren't spending time trying numbers that won't work. So if we can identify the domain, then we are saving time. This is really helpful if we're working with a computer that is trying to compute a bunch of values for us. We want to tell the computer there are some limitations here. Don't use these numbers, because otherwise your computer will be sitting there computing numbers that don't work. All right. The third restriction is when we have a radical, like a square root or even root of an expression also in the denominator of a fraction. So in that case, our expression has to just be greater than 0. We cannot have a negative number underneath the radical, and the denominator cannot be equal to 0. So that is why we set the expression to be greater than 0, where for restriction number 2, we are greater than or equal to 0. Because a standard square root, you can equal 0. But when it's in the denominator, you cannot equal 0. The other thing to note, that this is when the radical is an even value. Okay, so square root, fourth root, sixth root, not odds like cube root. Cube root, you can do any number you want, because negative numbers, you can take the cube root of a negative number. You cannot take the square root of a negative number, and you cannot take the square root of, or the fourth root of a negative number. All right, so let's look at an example for this third restriction. If we have 1 over the square root of, let's say 2x minus 5, that would mean I take 2x minus 5, which has to be greater than 0. I would add 5. I would get 2x greater than 5, and then divide by 2 to be x is greater than 2 and 1/2. So all the values greater than 2.5 can work. So I would say the domain is x such that x is greater than 2.5. As an interval notation, I would write 2.5 with a parenthesis, and that could go all the way to infinity, and I would use parentheses for that as well. Okay, so hopefully that's a review. Otherwise, hopefully you've learned and understand domain with that. Again, domain is allowing us to understand what values can be put into an equation or some kind of function and know which ones to use. And that's it.